In this video, we're going to take a look at a little part that one of the students wants to manufacture. And as you can see, it's kind of an odd shaped part. It, um, it has tapered sides and it has a couple of round features kind of built into the design of it. So it doesn't really set itself up real well for indicating on edges and down the middle and things like that. So the student wants to, of course, as I've instructed them to, chamfer both sides of this part. They want to chamfer the top, and then they also want to chamfer the back side or the bottom. So I've explained before that soft jaws are a great option for parts like this, as they are, but sometimes it's not, if it's just a onesie twosie type part, it's not worth it to take the time to machine soft jaws. So in this video, we're going to talk about a process in which you don't have to machine a set of soft jaws and you can still get the desired result. All right. All right, we're going to take a look at the wireframe geometry that we use to create the program to machine Operation 1 and Operation 2. This is a view that we're going to eliminate showing the vise and any other accessories. So I'm just going to show you the program itself. So over here on the left-hand side under my toolpaths, I have my operations, also known as my toolpath groups, broken into Operation 1 top and Operation 2 bottom. So right now we're just going to look at Operation 1 top, and we're going to run that. And I'm just going to speed through it. I'm not going to take my time with it. Let it just knock that out real quick. And as you can see, we area mill the outside perimeter, getting rid of all extra stock on the outside of this part. We machine the contour with our chamfer mill, as well as the pocket in the middle with the chamfer. And then as you can see here that we've discussed, we drill and ream a 3/8 hole directly through the part, all the way through. Now this could also be milled. It's preferable to use a drill and then ream it to size for precision's sake. But with CNCs, especially high quality CNCs like our Haas mills, you can mill this out as a pocket with a 1/4 inch end mill and it'll be just fine. Okay, so that is Operation 1. I'm going to go ahead and close this and select the bottom. I'm going to rotate this over so that we can look at the bottom of this. Actually, let me change my planes over to the bottom now. Okay, so we're looking at the bottom, and one thing that is different, rather than the 4x4 stock being centered on the origin, you can see I've shifted my origin on this Operation 2 to be the center of the drilled and reamed hole. So that's very important. You must shift your origin to that point, because when we flip it over in the vise, we're going to be indicating this hole in using a test indicator. So if you still have your origin at the center of where the 4-inch material 4x4 block was, it's going to make it a little bit difficult for you to establish this origin. Okay, so we're going to run Operation 2 bottom toolpaths. Kick this up to an isometric view. And there you go. So Operation 2 does basically the same thing as Operation 1, minus the hole that gets drilled through the part. And as I mentioned before, we machine down a little bit past the halfway point. So if we're using 3/4 inch stock, 375 being halfway, we're going to go down to maybe 385 on both sides. And it'll have a very slight blend line in the middle that may or may not even be noticeable. All right, so let me show you both of these operations ran at the same time. We'll click Machine Group, then we'll run Verify. There's Operation 1, Operation 2, and as you can see, there is the finished part. Okay, hope this helps. Let me know if you have any questions. A little bit. As you can see from the screen, I have the part located in our 6-inch Kurt vise. And I have the part on a couple of parallels that are gripping onto about 1/8 of an inch of the stock. Now, this particular stock is 4 inches by 4 inches by 3/4 of an inch thick. That's the material size that we're starting with. Both sides are parallel, and like I said, we're only gripping onto about 1/8 of an inch. Now this would work if you were using the next size smaller parallels where you were gripping onto about 1/4 of an inch. But for this demonstration, we're going to grab on 1/8 of an inch of the material, and then we're going to use our 2D area mill and pocket toolpath to machine away a little over half of the feature. Now the feature, obviously, as I showed earlier, is kind of a strange looking feature. It doesn't have any parallel sides, and obviously we want to chamfer both sides. So let me go ahead and run this so you can see what operation 1 is going to accomplish. Okay, so operation 1 machines just a little bit past halfway. So if this is 3/4 inch stock, we're going to face it and then we're going to machine, maybe 0.385 down, just a little past 375, so that we know that we're completely getting past halfway on this particular piece of stock. I've also chamfered the top side, and we've milled a pocket in the top side. But there's one additional feature here. And as you can see, we have drilled and reamed or machined using an end mill with a pocket tool path a hole that goes completely through the part. Now let me zoom out a little bit so you can see. I'll rotate this over. As you can see, this hole goes completely through the stock. Now in the next view that I'm going to queue up, you guys will see what operation 2 will be to finish machining this part. Alright, in this view we are looking at operation 2, also known as machining the bottom side of this part. So what we've done is we've flipped the part over and we're gripping onto about 1/8 of an inch of the finished material that's been finished to size. You could also probably use 1/4 inch lower parallels, just as long as you have enough clearance from where the end mill is going to have to machine to the top jaw. So let me rotate this a little bit sideways so you can see there we're gripping on to that 1/8 of an inch of the material. And on our top side, as you can see, we have our reference hole. Now this hole is the hole that we drilled and reamed or milled from the top side to use as a reference for our origin and the machine work on the bottom side. So let's go ahead and watch this get machined. Now to set this up in the mill, our surfaces of our jaw become our reference datum for our X and our Y axes, but we have to locate the X and Y axis by means of the origin point that we've established here. So a quick way to do that is to drop an edge finder in here, and you can ping back and forth with an edge finder. You can bring a drill chuck down with a 3/8 end mill and line up on it approximately. And then once you've done that to get it close, then you'll come and sweep an indicator around this hole to establish the origin point. Alright, so let's hit play. You can see there's our pocket, which completely eliminates the hole that we had there that we used for our reference. Next up, we've got our area mill that's taking the outer perimeter to size. And then final is our chamfer to finish chamfering the part. And as you can see, what we're left with is a completed machined part with chamfers on both sides, finished on both sides as well.